know? Okay, get rid of it. Okay. All right, here we go. We are starting 2-7, 5 slides. Here we go. It says use the graph over there to answer the following questions. Is this f of -1, is it a positive answer or is it a negative answer? Negative. Positive?
It's on a negative slope.
Okay. F of -1 means you're plugging what in? An x value of what? -1. So you plug in -1 right about here, and then you plug it in and you get what answer? That answer, which is really that answer. Is that positive or is that negative? Okay, you got a positive y value. And really what you're doing is you're looking at the graph and saying, is my answer positive or is my answer negative? Is f of 4 going to be greater than 0 or is f of 4 going to be less than 0? And it's every other interval is 1. That's 1, that's 2, that's 3. 4 is really over there somewhere. So if you put 4 into your function, where's the answer? It's up there. Way up here, which is what? Positive or negative?
It could just like turn. It's falling down at 3 points.
Okay, so you have a positive. Which one's going to be positive?
Plus, or
Greater than or less than 0?
Greater than.
Okay, greater than 0. So your answer to f of 4 will be greater than 0. Here it just said, is your answer to f of -1 positive or negative? What's positive? It's kind of the same question. When does your function f of x actually equal 0?
0.
So what I'm saying is, you put what x value in your function and get 0? 0. So you're telling me this one? I put 0 in, I get 0 out.
Yeah. And -2.
And what?
2 positive.
True. And what?
-2.
Yeah. So basically, when you say, when is f of x equal to 0, I'm asking you for the zeros of your function. So x equals 0, or x could be what? 2, or -2? Right?
Yes.
Okay, good. Next. Answer the next question. Over what intervals is f of x less than 0? So, first of all, do you guys remember from chapter 1? When I say intervals, what am I really saying?
X values.
X values, yeah. So yeah, I'm saying intervals, but I'm really saying over what x values is your function going to be what? Less than 0, which means okay. Well, where do you get negative answers? Look at your graph. On the bottom. Bottom, what does that mean?
Below 0.
What? Anywhere below the x-axis? Yeah. Guys, pick a point below the x-axis. This one? That's your negative answer. Negative. Negative. So when is your answer going to be less than 0? When's it going to be negative? Anything below the x-axis. But now I asked you for what x values. Well, I know -2 will get me what? 0. So is -2 an answer?
No.
Nope. But what is? Anything less than -2. So if you get way out here, guys, where are we at?
Negative.
Yeah, so you'd say from negative infinity all the way to what?
Negative.
All the way to -2. Should get me y values that are negative or less than 0. Is that it? No. Because if you look, these are all negative y's, but so are these? No.
Next.
These?
Those.
Yes. Here are your negative y's. So your interval will be what? What x values?
0.
From 0 to what?
2.
From 0 to 2 works too, right? 0 to what? 0 to 2. Yes.
Use greater than.
Yes, you can. But that was algebra 2. Algebra 2 said my answers are between here and here. Correct? Okay. To avoid the problem, Zach, which way is it? Less than? Is it this way? This way? It's much easier to say it in interval form. But Zach, if you wrote that on a test, I get it. I know what you're doing. I'm trying to tell you to write what though? Intervals. Okay? Zach, what you're saying is the same thing. That's what I'm saying. Okay? Okay, last one. Over what intervals does f of x, is f of x greater than 0? Brandon, do you know? 2 to what? Negative 2 to 0. That's what he says, yes? Greater than 0 would be where? All these y's that are positive up here, what x's actually gave me these y's? From here to here, negative 2 to 0, that's what Brandon said. Yeah? Yeah. That's it. So your interval notation looks like this. Now Zach wants me to go back to inequalities. And this works too, just so you know. That is the answer. That is the answer. Same thing. Okay? Can we move on? Do you get it? Really, that's the whole lesson, to be honest. Okay? Okay. Here, this one says, using your calculator, right there, determine the intervals where this function, right here, this function is going to be less than 0. I'm not making you graph it, guys. You're going to let your calculator do it. Go. I'll give you a minute to punch it in and graph it.
Okay.
Is it one six less than?
Whoa.
I put the y at 0. I put the y at 0. It says less than 0.
So you just
I'll give you the interval, right? So what x value will give you negative 1? Your minute is coming to an end. Some of you have not even stood up to get a calculator. Shut that off. You have
That's the one.
oh.
you have that cheat sheet from Friday?
Good job.
You don't even need one to Friday?
This one's 2.4.
Did you have it?
Oh, got it,
Okay, that's yes. All right, did you graph it? Yeah? I think if you put it on a 10 by 10 window, I think it's fine. Right? Okay. Yes, no?
Yes.
Something like that? Yeah? Okay. Well, here's the deal. Here's the deal. They're asking you this. This is what they're saying. What x values, when you plug it in, will give you what? Numbers that are what? Less than 0. Less than. Well, less than 0 means what? Negative. So I put an x in, and I get a negative answer out. Well, if you put in this number, let's see, 1, 2, 3, 4. If you put a 4 in, you got what out? A positive. They want a negative. So no, not that side. It's what? It's down here. So what's really important is we know the what. We got to know the 0. So guys, you need to find this 0, this one, and this one. Okay? How do you do that? Second. Trace, but that's just calculate. What are you calculating? The zeros. Okay. I need answers. So if this side of the room will do the left side, and this side of the room does the right side, I'll get my answers quick. Anybody got anything? Yeah, Zach, what is it?
For the left side.
Yep.
It is negative 2.43.
This one?
Yeah.
Okay.
And then 0.65.
Negative?
Yes.
Okay. That's what Zach is telling me. Is that right? Okay. Okay, so we got zeros on the left, zeros on the right.
The first one that goes to the origin, and that one is 0.855.
Okay, this one?
Alright, you do that with this.
Anybody got this one? 2 point what? 2.2. Okay. Hey guys, when you do your problems today, you need to know your zeros, because your zeros are like, on this side of the zero, you get negatives. On this side of the zero, you get positives. And since it's going to say greater than 0 and less than 0, you better know what your zeros are. So, what makes all these answers negative? From here to here. And from here to here. So if you set it in interval notation, you would say, from what to what? You know, 2.43 comma what? Negative 0.65. Okay? And there's more answers. They're what? 0.85 to what? 2.22? There you go. Good? Can I tell you something? Here's what's going to happen. If you ever get this symbol equal, now I'm saying what x values are less than 0 and equal to 0. How's that going to change this look? Now what?
Brackets.
Brackets. Brackets mean that this negative 2.43 actually works. It does, because it makes it what? Exactly 0. Okay? So does this one. So does this one. So brackets mean yes, they are included. Parentheses mean no, they're not included. Okay? You okay? How do we do it without a calculator? See that? How do we do it? What? We factor it. We get our zeros.
Yeah.
Go, do it. Start by doing what? Taking out an x. Looking inside. Trinomial. Maybe it factors into two binomials, does it?
X minus 4x plus 2.
X minus 4x plus what?
2.
2. Okay, you got it. So right there, guys, you just found what? 3 factors, which means 3 zeros. They are what? 0, 4, negative 2, got it. Why do you think I made this little table? I'm also going to ask you this. Multiplicity. X to the first, x minus 4 to the first, right? 1, 1, 1, isn't it? And do you remember what 1, 1, 1 means? It goes through the x-axis, through the x-axis, through the x-axis. What if it would have been a 2? Bounce. Bounce, okay? Now, one more thing before I graph this. Tell me the end behavior. Look at this, right here. That's odd. That's positive. So the end behavior is what? Down on the left. Up on the right. It acts like a line because it's odd. And why is it going up? And not down? It was positive x cubed. Okay, so the end behavior is important to you. Okay, so let's make a quick sketch. Here we go. Zeros are 0, 4, negative 2. End behavior is what on the left? Down. On the right? What's it going to do at every one of these zeros? Goes through, goes through, goes through. Why? Why? Odd. Odd multiplicity goes through. See, there it is. I'm done. That's it. Now, did I graph it perfectly? No. I did here, here, here. That's perfect. How high? I don't know. How low? I don't know. I don't really care though. How come? I just need to know, here it is, what x values make it greater than 0? Make it what? Positive. Well, when I look at a graph, all the positive y values are above the x-axis, right? Okay. So there's where the y values are greater than 0. Now, what are the intervals that work here? Intervals are from here to here, which would be what to what? To what? 0. Gotcha. And then what? 4 to infinity. Yeah? So if you look at a graph, is it pretty easy to answer that question? If you graph it correctly, it's really easy. If you graph it incorrectly, it's still pretty easy. It's just that it's going to be what? It's going to be wrong because you graphed it incorrectly. Okay. Move on. Yeah? Okay. Some quick steps that we just did. What did we do right away? We just kind of found the what? Zeros, that's what we did. Then we plotted them on a number line. No, we didn't. We plotted them on what? Then we put the zeros on the x-axis. Yep. Then we tested a number in each interval to find its sign. No, we didn't. What we did was we looked at end behavior and multiplicity of Howard, of the zeros. Okay. I thought we were gonna. Can you? Yeah. Can you text one of these students here?
Yeah.
To get the assignment.
Yeah.
127.
Okay.
Okay. So, guys, here's the deal. We looked at the end behavior and the multiplicity of the zeros, right? Bounce, or goes through. Then we consolidated your findings into what? Intervals, which are your what? Those are your x values, right? Or better yet, those are your answers. Okay. So that's what we just did. Cool. Yeah? Okay. Now, can we move on to the hardest problem? Why is this the hardest problem? Because it's a rational function, which is a fraction. It's what you did yesterday on your 1 through 7 assignment. Okay, so here's the deal. It says, what additional things besides zeros do we need to consider? Okay, look at that. Serena, what do you think? The wholes. It isn't so much the wholes, no. Okay, first of all, why are zeros so important? Because on this side of the zero, you might have negative y's. On this side, you might have what? Positive y's. That's why they're so important. There's something else. What's this? Vertical asymptotes. Because look, on this side, you might have only positives. On this side, you might have what? Only negatives. So what's really important are your zeros and what else? Vertical asymptotes. Okay? These are really important too. So basically, when you hit a zero, on this side it could be negative, on this side it could be positive. Same thing with vertical asymptotes. Okay, so let me get rid of this picture and let's do it. Ready? We're just gonna make a sketch, right? All right, you ready? Looking at this, on the bottom tells me what? What does the bottom tell you? X-intercepts, no? Domain, yes, but better than domain. Vertical asymptotes. What's your vertical asymptote? Don't say 1. Say x equals 1, okay? Okay, what does the top tell us? Where what? You're right. Although I don't care, because I only care about this. I only care about this. I mean, you get it? But I care about this and this. Okay? Zeros. This tells me what? Zeros. Where are my zeros? 2 and negative 1. So 2 comma 0 is a 0 and what? Negative 1, 0. There you go. So really, guys, all I care about are these two things when it comes to rational. Zeros and vertical asymptotes. Okay? So if I do this right now, okay? Negative 1, right here, at 1. Okay? There's your vertical. Your zeros are what? 2 and negative 1. Okay. What else? And behavior. Well, yeah, you know what I want to do here? Can I do the multiplicity below? Multiplicity is what on this one? 2. This one? 1. And if you get a multiplicity of 2, what do you know? It does bounce. What do you know here? It should go through, right? Okay, I think, yeah, we're done. That's all we care about is the zeros and the vertical. I was thinking of something else, but here's the deal. You do know this. If it's a 0, on this side it could be positive, this side could be negative. But at this number 2, what do you know? Multiplicity is 2. It does what? It does bounce. Now, is it going to bounce like this? Or is it going to bounce like this? How would you know? You're not going to know unless you plug it in, plug a number in. If I plugged in 2, I'd get 0. I know that. Maybe plug in what? 3. Go plug it in, guys. See what you get, and I'm going to wait for you. Hey guys, what were these two factors up here? X minus what? 2 squared. And then what? X plus 1? Okay. So you guys, did you already plug in the 3?
Yeah.
On the bottom is x minus 1, not x minus 3.
Oh, yeah. Got it. You're right. Okay.
You get 2.
Okay. Plug in the 3, what'd you get?
2.
You got a 2?
Yep.
You ever get 2?
Yep.
Okay, well, there's 2. Oh, 1, 3, 2. Okay, so up what? 2. There. Hey, look. See that? What's it going to do? Is it going to go through or bounce? If it bounces, like you're telling me, now it's going to do what? Wait, that's a vertical asymptote. It's going to ride it all the way up. Okay? This one goes up like this. Okay? Looks like a parabola. Hey, looks like a parabola on the right side. Okay, on the left side of the vertical asymptote, something else could happen. Well, one thing I do know, it's going to hit this point, and because the multiplicity is 1, it's going to what? It's going to go through. Now, either it goes through like this, and rides this one down, or it comes through like this, and rides this one up. I don't know. Okay, how are we going to know? We'd have to plug in probably
Negative 0.
plug 0.
Why can't you do negative 2?
You can't, I will do that next. Okay,
Well,
plug
you
in
get
0.
5 if you put in 2. So.
Okay, 0 goes in, what'd you get? Negative 4. Okay, so negative 4. Right here. Okay, guys, now look at this. It went from here to here, and it's going to follow the vertical asymptote all the way down, just ride straight down. Now this one, you can already tell it's angling this way, right? So go find the next number, negative 2. Negative 2 gets you what? You think it's 5? Or thirds?
5 and 1/3.
Is it 5 and a third?
5 and 1/3.
Okay. 16 thirds, isn't it? Yeah, I think it's 16 thirds, 5 and 3. All right. There it goes. You got it? Okay. So guys, that's it. You got zeros here. You got the vertical azimuth here. Now, where is your function? Look up here. What does that say? So what I'm saying is, what x values go in that pump out y values that are greater than 0? So where are they what? Where are the y values positive? Would that be above? Right? Now, what x values actually gave us these? From here to here. What would that be? Okay. Good? What about these? These are all what y values? Negative. I want positive. Okay. What about these y values? Are they all positive?
Yes.
Yeah. And I want positive. Yeah. So what x values actually did it? From what? 1 to what? Infinity. Okay. Now, can I tell you that in the back of the book, they're going to graph these things? And I want to show you. I don't want you to freak out because it's nothing big. Because here's what it is. If they graph it in the back of the book, here's what it looks like. Here's 0, 1, 2. Okay. To graph that, you'd say from negative 1 to negative infinity. It'd be from here to here, right? Isn't that what that says?
Yeah.
These are all the answers. What does that one say?
1.
From 1 to what?
Infinity.
Okay, so that's what they do. But I think they even change it slightly. They go like this. They don't use open and closed circles. They use the parentheses. So they might do this to you. They might do this. And I think they do. They go parenthesis, and they go parenthesis. And all a parenthesis means is that number, negative 1, is not a solution. But remember, if this thing would have had an equal sign, then guess what they do? They use brackets. Because brackets mean negative 1 gives you 0, which works. So when will the bracket appear? When you have an equal sign. When does the bracket not appear? When you don't have equal signs. Okay. So this is what I'm telling you I will accept. But they will do this to you in the back of the book. When you check your answers. You good? Okay. Here's the assignment. I don't have calendars.
It's been stamped.
Only on the surface layer. The archer was a very bad shot.
That's just rude.
There it is.
Happy.
Copy. Look. That would